Okay, so now we're going to move on to Handout. Creating my own videos. 5.1. Alright, we're going to be talking about z-score. Alright, so why is the z-score important? We've already kind of hit on that. If you read the book by now, you understand that the reason why we want to use this is we want to be able to sort of compare apples to apples and oranges to oranges and kind of figure out where on the normal curve these things sit. So if you think about it, we're also, in order to do these problems, we're going to be using the appendix in the back of the book. Let me get my book ready. Alright, so we're going to be using the appendix tables, and I'll pull these up in a second as well. This concept, and also what table 5.1 asks you, I'm setting it up now. It's going to give us the scores. First we have to know how to get a z-score. In order to get a z-score, you'll have to know three things. You'll have to know, we've got the x-bar, which is our average. We'll have to have our x, or our score that we're looking at. We'll also need our standard deviation. And so what you're going to do is you're going to take your x minus your x bar over your standard deviation. This will give you a z-score. And it's this z-score that we're going to use to go into the back of the tables to actually compare two things. Alright, so Handout 5.1 gives you the scores, asks you to calculate the z-score for each number, and then lists in the back, I'm just going to put on here, the probability. Alright, of selecting something like that. My scores are 9, 5.5, 4, 8, 6.5, and the problem also tells you what the average is, as well as what the standard deviation is. For this set, we know that n is equal to 35, I believe. Yeah. It tells you that n is equal to 35. But remember, our formula didn't call for that. Also lets me know that the mean score on this test, x bar, is equal to 7.2, and that my standard deviation is equal to 1.5. So to figure out the z-score, I'm going to take each of these and try to figure out where it is. You're going to take your 9 minus your x bar, 7.2, and divide that by your s, 1.5, which is going to give me 1.20. Right? For the next score, 5.5, I'm going to take 5.5 minus 7.2, 5.5 minus 7.2 divided by 1.5, right, which is going to give me negative 1.13. Right, and you keep going all the way down, and I've already done these, so I will go ahead and list them here so you can check your work. You can go ahead and pause if you want to and go ahead and finish out the problems. So by now you should have gotten 1.2, negative 1.13. And this negative makes sense because this 5.5 obviously is below the mean of 7.2. So it's going to be on the left side. Negative 1.78, 0.53, and negative 0.47. It's these z-scores that we're going to use to go into the back of the book, the appendix. Alright, and so you're going to be using your normal unit table. And the way this is broken down at any of them is, I'll give you your z-scores in the first column. I'm going to try to focus this a little bit better if you don't mind. Alright, and as you can tell, here it gives you, this is just giving you an example of the proportion of the body of the bee. And so this will tell you everything on the left side of your z-score, everything on the right. Alright. So if you go down your z-scores, and we want to know, let's say, and then the D area here will tell you, and I like the D column, because I think that's the way our book is written down. D, the D column in this book will tell you the distance between the mean and your Z. So for example, if I wanted to know everything below this particular Z, I would have to take this area here plus this 0.5. Remember, this area here is equal to nothing but 0.5. Right, so the first one I have is 1.2. You come into your z-table, and so all I want to know is what's the probability of selecting somebody with a 1.2. Tells me it's going to be 0.3849. 0.3849. 0.3849. All right. Negative 1.13. Notice, remember, probability is all positive, so you don't have a negative. You just find 1.13. 1.13 is going to correspond with 0.3708. 1.13 corresponds with 0.3708. 0.3708. Alright, and I'm going to go ahead and fill out the rest of the chart. If you want to go ahead and finish up, you can, and then come back and check to see how many of them you actually got correct. Okay, so this is the solution to Handout 5.1. First you get your scores, then you convert to your z-score, and again the formula is just going to be x minus x bar over your standard deviation. Give you the z-score, then you go into the back of the book to get the probability.